Okay, so here is our 1.B, our Unit B test review practice problems. Alright, so again, I'm just using this little guide here for each thing. Decide if something is an H or a K value. So the function here, this is a linear, this is y equals x, just a linear function, and it's been added 2, has been added to it, so that's going to move it up 2, so we just say up 2. This next one has the minus 3 on the outside, so it's down 3. This one's a quadratic. I guess it does say write the parent function, so this one's also y equals x, linear, and this is y equals x squared, and it's quadratic, and it's up 2. Let's see, now we've got stuff on the inside. So if I pull down my little model here, these are h values when you're inside the squared function or inside the absolute value. So these are h's, and it's always the opposite sign. So this is a -1 is what we see, but that means the h is a positive 1. So this is right 1. Again, this is quadratic, y equals x squared. This is an absolute value. It's going to be left 4. So h is -4. And the last one's kind of a weird one. This is our constant function. You gotta remember this about the constant function. The parent is y equals 1. So it's normally right here, y equals 1. This new function is y equals 5. 1, 2, 3, 4, 5. So it's up here. And that means it's gone up by 4, so this is up 4. Next, again, I'll name parents and tell you what's going on with the transformation. So here we've got, when it's out front like this, okay, these are generally considered A values, and that's the easiest thing to do. A B value you'd know it's a B value when they've done something like this, a, y equals, and they put the 3 on the inside of parentheses. Now, it turns out with linear functions, this is linear, x to the first. When you put the 3 inside with the x, when you simplify it, it ends up looking just like this guy. And so there's actually 2 ways to describe this problem. But the easiest is to treat it like an A. And when A is present, it causes a vertical stretch or shrink. Okay, in this case, because it's A3, A equals 3, that will stretch it just by 3. It just multiplies all your y values by 3. Here it has a half out front, so that's vertical. And since it's a half, that will make it shorter, so it's a shrink. Because when you multiply your y's by a half, they get smaller. Shrink by a half, they'll be half as tall. Number 8, the 3's on the outside of the squared, so that's a vertical, and this will be a stretch for this quadratic by 3. The 1/4, let me just show you, this is an A value again, A equals 1/4. If it were a B value, it would be inside the parentheses, like that. Notice the squared's on the outside, the B is on the inside of what's being squared. So that's a B. This A's on the outside, and so we go vertical stretch. Oops, sorry, shrink. This is a 1/4 vertical shrink. I can spell shrink, vertical shrink by 1/4. Small numbers make us shorter. This is an absolute value function in number 11. It's got a 2 out front, so it's a vertical stretch. You would have to write the whole thing down here. Okay, I'm abbreviating, but you write the word vertical stretch by 2, and then there's 5/2 out there. 5/2 is bigger than 1, so this is also a vertical, and it's a stretch, and it's by 5/2. 13's got 2 things going on. It's got an A value, that's a 1/3, it's going to shrink it, and it's got a K value out back here, so it's going to drop it down by 1. So I'll abbreviate, but you write it all out. Vertical shrink by 1/3 and down 1. see here, the 2's in A equals 2, so vertical stretch by 2, down 3 because of the 3 on the end. And last quadratic here, the 5/3 is your A. 5/3 is greater than 1, so it's a vertical stretch by 5/3. And then it is also up 2 because of that K value right there. So that's the front side of it. They don't take very long. And then the back. On the back here, I'll try and organize this. Number 1, start with the new function based off the old function, and then we'll figure out exactly what it is. It wants us to go right 5. That means you're going to have to do the x plus 5 inside the, x minus 5, sorry, to make it go right 5. So in this function f of x here, we're going to change it from x to x minus 5. And that'll make it move to the right by 5. Now, you have to now calculate the real function. So function f is 5x minus 2. 5, not x anymore though, because we're plugging in x minus 5. So 5, we replace the x, and then the function says then subtract 2. So it's 5, replace the x, minus 2. And then I simplify. Distribute the 5, subtract the 2. And there's the answer to number 1. That's what our new function equals. All right, I'm going to grab that stuff and slide him out of the way, I hope, right here. I'll do problem number 2. Problem 2, I want to go up by 4. That means take the original function and just add 4 to him. So the original function is 3x plus 6, and then I add 4 to him, giving me my answer, 3x plus 10. That's my new function, and he will be 4 higher. It's pretty easy. Problem 3, very similar to the first one. I want this one to go left 2, so I need the f of x plus 2. That makes him go left 2. I just go to my function. My function is 3 minus absolute value of x, but my x is getting replaced with x plus 2 to make it move to the left. Then my function continues with a minus and a 2. And then I end my absolute value and I simplify. Let's see here. Inside there, 2 minus 2 is 0, so there's my new function. G of x is that, 3 minus absolute value of x. And then my last one in this group here, number 4, let's see what we have to do. 2 down. So g of x equals f of x, and take it away 2 to make it go down 2. I rewrite f of x using its actual function. That's what f of x is. You can see it right there. Then it says down 2, so I have to go minus 2. Or absolute value of 2x, and 3 minus 2 is 1. And there is my function, f of x, translated down to units. All right, now we're going to do reflections. The only thing you have to remember about reflections is over x axis, g of x is the opposite of f of x, and over y axis, left to right, g of x is the f of the opposite of x, so I have to put a negative x in there. So here I want y axis, so g of x is f of negative x. That's this one right down here. And then that just says go to function f right here and put in a negative x. Okay, so I'm going to do that right up here. You can see I'm putting in a negative x for 3. I've got my minus my x. I've replaced it with a negative x, and I put it in parentheses when I substituted, plus 3. This double negative becomes positive x. Now usually you work it right below your thing here, so it would be negative of negative x plus 3. My equal sign down just a little bit, bugging me. And those two negatives then make a positive. So your final answer, x plus 3. That's your new function for problem 5. Just put in negative x for the x. Simple enough. All right, let's take a look at 6 here. 6 now we're doing over the x-axis. So that's this one. G of x equals the opposite of f of x. I just put a negative in front. I repeat my negative sign, and then I replace f of x with what it actually is. I want the opposite of the function, the opposite of the function. And I can distribute that negative sign. It becomes negative 2/3 x plus 4. And there's my answer. Slide him out, number 7. Over the y-axis, I need to put a negative on the inside. So g of x equals f of negative x. There's my negative sign stuck into the middle. And then I just do that to my function. So here's my function, negative 5 plus sign. Then comes the absolute value. Then comes x, but x is getting replaced with this negative x. Then my function says now subtract 8, and then end your absolute value. And that's really it. I don't want to absolute value anything. I would leave it just like that. Absolute values you rarely simplify. There are some instances, but we haven't talked about them. If there's like, numbers you can just add inside, you just do that. All right, last one, reflect over the y-axis. I just did a reflect over the y-axis, but we'll do another one. So g of x equals, over the y-axis, the f of, again, I put in a negative x. And so I'm just going to rewrite function f, but I'm going to put that negative x in there. And so it is absolute value 4. I replace my x with negative x, minus 1, minus 2. Notice I had to write the whole function here. And I can simplify that a little bit. I got an absolute value. 4 times negative x is negative 4x. Then comes my minus 1, and my minus 2. And so that would be your simplest solution for g of x. Last few here, we're going to stop at 12. We don't have any, I don't think, like 13 or 14. Here comes problem 9. I got to start doing horizontal stretches. Horizontal, that's a b value, and the factor is 2. But that means I got to use the reciprocal. So this is going to have a b of a half for horizontals. Vertical shrinks, that's a equals whatever the number is. Horizontal shrink, that means b equals the reciprocal. And vertical stretch, that means a equals 2. Okay, so let's do that. Now remember where those b's go, for example. So g of x equals f of, if I want a horizontal, it has to go right in front of the x here, and it's whatever that b value is. Factor of 2 means b's a half because it's horizontal, so I put a half right there. And then my function, to figure it out, just simply says find the f of negative a half x. So I just rewrite my function, but when I get to the x, I replace it with a half x. And that's my answer. You might want to put the slope part first because this is just a line, but that's the same equation. Most of us would just leave it like that. There you go. I just horizontally stretched it by a factor of 2 by putting that half x inside there. That's all there is to it. Let's do another one. Vertical shrink. That means g of x is, verticals go on the outside. 1/3 of f of x. So 1/3 of, let's see, my f of x is 3x plus 5 in this problem. Just have to distribute the 1/3. 1/3 times 3 is 1x. 1/3 times 5 is 5/3. And there is my new function. Then comes 10. Horizontal shrink, so I got to use a b of 3. So g of x equals f of, here comes the b value of 3x. So I'm putting 3x in for that x. Kind of tricky because there's already a 3x there, but that's all right. It goes absolute value 3. Then I replace my x with 3x, so I get double 3's in there, then plus 2. Oops, that plus 2 is on the outside. And that gives me a 9x on the inside plus 2. And that is now shrunk by a factor of 3, or stretched horizontally, shrunk by a factor of 3, or, yeah, horizontally shrunk by a factor of 3. Sorry. Let's see here. Number 12. Things went so fast. Number 12, our last one. Vertical stretch by a factor of 2, so g of x equals 2 times f of x. Vertical stretches, you just use the number. 2 times f of x is negative 2 times x minus 2 plus 4. Let's see here. I can take this 2 times negative 2 right there, which will give me negative 4. times x minus 2. That doubles the first term, but I got a second term way over here that I have to double as well. And so there would be the g of x for number 12. I had to double the whole thing to get the whole thing to stretch by a factor of 2. All right, that is it. The last couple you don't have to worry about. Those are compound ones, and that should be enough.